give the shape that describes each hybrid orbital set. And we have sp3d. So in this case, I guess we have to draw the shape, right? Give the shape. I guess we'll draw it, right? We'll draw the shape of what sp3d hybridization is. So the easiest way to do this is we're just going to break this down into how many letters do we see. So from sp3d, it seems like I have one S, and when it comes to the P's, I have three P's. So P, gotta go P. And then we have one D. So if I count up all of those letters, it seems like I have 5 total letters. All right, well, what does that really mean? Well, when it comes down to an atom trying to bind, and let's just say that this little black dot here is the nucleus of an atom, we basically have to draw 5 separate orbitals, 1s, 3p, and 1d, around this nucleus. So, to help us out, it's always based off of the circle. And if I can, I guess, draw the circle, maybe if I give my shape tool a little help here, that's much better. So we're going to try to draw it in this little shape. So, the sp3d is probably the hardest one because you have 2 things going on here in order to make your drawing perfect. Now you have to fit 5 total orbitals in this drawing. And many of you would say, well, here's a circle. Let's just cut the circle into 5 even pieces. And you're absolutely correct. But we just have to give it 3-dimensional purpose here, because orbitals in real life are not 2D, they're 3D. So let's first do the 180. Now, the 2 of the orbitals are going to be linear to each other, which means that they're going to be completely 180 degrees. So that takes care of 2 of them. There you go. I'll color them in at the end. So that takes care of the 2 out of the 3. The next 2 is basically going to be acting as your, how do I put this? It's basically going to be acting as a 3-sliced pie, where it's 120 degrees in the other direction. So this is where you're going to start having 3-dimensional objects. So, for example, if one of them is coming out this way, the other 2 have to be going one in the front and one in the back. Now, technically, I just drew like a, 5-membered flower, but I will now take this away and I'll kind of draw the bond angles. So, here's 1, here's 2, and let's see, here's 3. It's kind of looking like a cute little flower, right? Okay, and just keep in mind that one of these is an s orbital, the other one is 3 p's, and then the last one is a d. It doesn't matter which one you draw as which. But just know now that you have 2 different bond angles here because there's 3-dimensional character. This bond, or this orbital and this orbital, are 90 degrees from each other. So maybe I'll draw like a 90-degreeer right here. So you got 90 degrees. You also got 90 degrees right here because the total of this to this is 180. So that has like no 3-dimensional shapes to it. However, when we start now talking about this orbital in relation to this, you're spanning this way. So you kind of go over this orbital. And it turns out that that is 120 degrees. And if you span backwards behind this other one, now you can maybe see that it's, 3-dimensional. This also is 120. And then these 2 would finish out the 120. So you have 2 different circles going on at the same time. You have a circle that's going this way and a circle that's going this way, giving the 5 orbitals. Now, if I had to draw this in real life, maybe it would be kind of like a sulfur in the middle with 5 oxygens, or not 5 oxygens, maybe 5 fluorines. So we'll have 1 fluorine up here. We'll have another fluorine over here. We'll have the one down here. And then if we wanted to draw this one in the front and this one going in the back, this line designates that this orbital is coming out in the front and this orbital is going in the back. And that kind of gives you the showing of what's going on here. So this would be like SFF F5, yeah. And then, if we just draw the lone pairs around the fluorine, because everybody has to have the octet. The sulfur can have the expanded octet because it can have access to those d orbitals. So we're good now. And I think that's it. I think that's all that I wanted to cover. But I just wanted to show you that for your sulfur, you just got to count up those bonds. 1, 2, 3, 4, 5. And that's who the central element is supposed to mimic. And that's it. I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel, and I hope you're having a great day. Let's keep studying hard, and I will talk to you soon. Bye-bye.